Such a great question. It should be so easy to define what a number is, but it's not. It's a slippery slope. There are many things we agree are numbers, right? Like 1, 2, 3, 4, the natural numbers. Those should be numbers. 0, we use it all the time. The negative numbers, we use them all the time when we add and subtract. So all of those are numbers. Now, we also use fractions all the time. 3/4, 7/5. Those are all numbers, the rationals. Now, when we do geometry, even with integer coordinates, so for example, a right triangle of side length 1, the diagonal has length the square root of 2. And that is a real number. That's a non-repeating decimal. So I think that's number 2. So all the decimal expansions, those are the real numbers. Those are numbers. But now a square root of 2 is a root of a polynomial, of the polynomial x squared minus 2 equals 0. So there are other roots, like what is a root of x squared plus 1 equals 0? That is I, a complex imaginary number. Is that a number? It feels like a number, so yeah, that's a number. So that makes the complex numbers numbers. Now here is where things get complicated, because the complex numbers are isomorphic to polynomials with real coefficients modulo the relationship that x squared plus 1 equals 0. That is isomorphic to the complex numbers. So the complex numbers are just polynomials with a certain congruent relation. So are polynomials also numbers? I think so. They also behave just like numbers. So in general, I consider a number any element of a field. And a field is a special type of number system where there is an addition and a multiplication that satisfies certain nice properties, such as the rational numbers is a field, the real numbers is a field, the complex numbers is a field. But there are other things that are fields, such as there are finite fields, there is fields of functions. So is a function a number? Well, they behave like numbers. For example, well, the number 3 is the function that is constantly equals to 3. And that's a number. But functions, they also have an addition and a multiplication, so they also behave like numbers. So you can also think of them as numbers, and I think that's the most natural definition of a number. A number is an element of a field. That's it.